What if I told you that NASA has been running a classified mission for over a decade, scanning the cosmos with technology so advanced that it can detect the chemical signatures of life from thousands of light years away? What if I told you that this mission has already identified over 40 exoplanets with atmospheric compositions that could indicate biological activity? And what if I told you that they're not talking about it publicly because what they've found might fundamentally change humanity's understanding of our place in the universe? This isn't conspiracy theory speculation. This isn't science fiction. This is the James Webb Space Telescope's Atmospheric Composition Program, a mission so sensitive and so groundbreaking that NASA has classified most of its findings while they verify what might be the most important discovery in human history. Welcome to Space Prime. I'm your host, and today we're diving into the most secretive and potentially revolutionary mission NASA has ever undertaken, the systematic search for extraterrestrial life using technology that's literally rewriting the textbook on what's possible in space exploration. The truth about what they've found might be more incredible than anyone imagined. The hidden mission. Let me tell you about a program that most people have never heard of, despite it being one of the most important scientific endeavors in human history. While everyone was focused on Webb's stunning images of distant galaxies and nebulae, a small team of scientists has been using this revolutionary telescope for something far more profound, systematically analyzing the atmospheric composition of potentially habitable exoplanets to search for biosignatures, chemical markers that could only be produced by living organisms. The program is officially called the Exoplanet Atmospheric Characterization Initiative, but insiders refer to it as Project Goldilocks. The name isn't just about finding planets in the habitable zone. It's about finding worlds where conditions are just right for the complex chemistry that indicates active biology. Here's what makes this mission so extraordinary. Webb's infrared capabilities allow it to detect incredibly subtle chemical signatures in the atmospheres of planets orbiting other stars. We're talking about identifying specific molecules like oxygen, methane, water vapor, and even more exotic compounds that could only exist in the presence of biological processes. But here's where it gets interesting and secretive. While NASA publishes some atmospheric data from Webb observations, there's an entire classification system in place for results that show anomalous atmospheric compositions. Planets that exhibit chemical signatures inconsistent with known non-biological processes are flagged for additional observation and classified pending verification. Sources within the program suggest that over 40 exoplanets have been flagged for exhibiting atmospheric anomalies that current models cannot explain through geological or chemical processes alone. These worlds are now under continuous observation by Webb and other advanced telescopes as scientists work to either rule out biological explanations or confirm what would be the greatest discovery in human history. The reason for the secrecy? NASA learned from previous false alarms about potential life discoveries. They're not making any public announcements until they're absolutely certain of their findings. The breakthrough technology. To understand why this mission is so revolutionary, you need to understand just how incredibly advanced Webb's atmospheric analysis capabilities really are. When light from a distant star passes through the atmosphere of an orbiting planet, that atmosphere absorbs specific wavelengths of light depending on what molecules are present. It's like each atmospheric component leaves a unique fingerprint in the starlight that reaches us. Webb's infrared sensors are so sensitive they can detect these molecular fingerprints from planets thousands of light years away. We're talking about technology that can identify the presence of water vapor in an atmosphere around a star you can barely see with the naked eye. But the real breakthrough isn't just detecting individual molecules, it's detecting molecular combinations that shouldn't exist together unless there's an active biological process maintaining them. For example, oxygen and methane are chemically reactive. They destroy each other through oxidation. If you find significant amounts of both gases in an atmosphere, something must be continuously producing them to maintain that chemical imbalance. On Earth, that something is life. Plants producing oxygen, bacteria producing methane. Webb can also detect more exotic biosignatures. Phosphine, which on Earth is only produced by anaerobic bacteria. Dimethyl sulfide, which is exclusively produced by living organisms. Even chlorophyll signatures that could indicate photosynthetic life on distant worlds. The program has developed an AI system called ARTEMIS, atmospheric recognition technology for extraterrestrial molecular identification systems that can analyze spectroscopic data in real time and flag atmospheric compositions that don't match any known non-biological process. Artemis has been running continuously since Webb became operational, automatically scanning every exoplanet observation for potential biosignatures. When it finds something anomalous, the data is immediately classified and forwarded to a small team of specialists for verification. The classified discoveries. Now we get to the part that NASA doesn't want you to know about, at least not yet. According to leaked information from sources within the program, Artemis has identified atmospheric signatures on multiple exoplanets that cannot be explained by any known non-biological process. We're not talking about marginal cases or uncertain data. We're talking about clear, repeatable observations of atmospheric chemistry that strongly suggests active biology. The most significant case involves a planet designated K2-18b, located 124 light-years away in the constellation Leo. This world, which is about 2.6 times the size of Earth, sits squarely in its star's habitable zone. Webb's observations have detected not just water vapor in its atmosphere, but a combination of gases that, according to current models, can only be maintained by biological processes. The planet shows strong signatures of hydrogen sulfide and ammonia in ratios that match what we see around hydrothermal vents on Earth, environments where some of our planet's most primitive life forms thrive. But more intriguingly, there are trace amounts of phosphine and what appears to be organic sulfur compounds that have no known geological source. Another case involves TOI 715b, a super-Earth just 137 light-years away. This planet's atmosphere contains oxygen and methane in concentrations that would require massive biological activity to maintain. The oxygen levels alone suggest either extensive photosynthetic activity or some other biological process we haven't encountered before. But perhaps the most extraordinary case involves TRAPPIST-1e, one of 7 Earth-sized planets orbiting an ultra-cool dwarf star just 40 light-years away. Webb has detected what can only be described as seasonal variations in atmospheric composition, chemical changes that follow the planet's orbital cycle in ways that suggest active biological responses to changing environmental conditions. The implications are staggering. If these observations are correct, we're not just looking at one potentially inhabited world. We're looking at evidence that life might be common throughout the galaxy. The verification protocol. Here's why NASA is being so secretive about these potential discoveries. They've developed an incredibly rigorous verification protocol to avoid false positives that could mislead the public or damage the credibility of the scientific community. The protocol, known internally as the Extraordinary Claims Verification System, requires multiple independent confirmations before any biosignature detection can be considered authentic. First, the initial Artemis detection must be confirmed by human analysis from at least 3 independent research teams. Then, the observation must be repeated by Webb at different times to confirm the atmospheric signature is consistent and not the result of temporary atmospheric phenomena. Next, other telescopes must confirm the findings. The Hubble Space Telescope, ground-based observatories, and even radio telescopes are tasked with gathering additional data about these target worlds to build a comprehensive picture of their atmospheric and environmental conditions. The most stringent requirement is what they call biological exclusion testing, exhaustively modeling every possible non-biological explanation for the observed atmospheric chemistry. Teams of geologists, atmospheric chemists, and planetary scientists work to identify any geological, chemical, or physical process that could produce the observed signatures without involving life. Only after all non-biological explanations have been ruled out, and after the observations have been confirmed by multiple independent sources over extended periods, can a discovery be classified as a potential biosignature detection. According to sources within the program, several of the flagged planets are currently in advanced stages of this verification process. The most promising cases have already passed the initial confirmation and repetition phases and are now undergoing biological exclusion testing. The timeline for completing these verifications varies, but sources suggest that definitive results for the most promising candidates could be announced within the next 18 to 24 months. The political dimension. But there's another reason for the secrecy surrounding this program, and it has nothing to do with scientific verification. It has to do with the potential social, political, and economic implications of confirming extraterrestrial life. NASA has been quietly working with government agencies, religious organizations, and international partners to develop protocols for announcing the discovery of extraterrestrial life. These preparations, known as the Post-Detection Task Group, involve everyone from sociologists to national security experts to religious leaders. The concern isn't just about public panic, though that is a consideration. The bigger worry is about the long-term implications for human society, economics, and geopolitics. The confirmation of extraterrestrial life would be the most significant event in human history, potentially affecting everything from stock markets to religious beliefs to international relations. There are also practical considerations. If life is confirmed on multiple worlds, it suggests that biology might be common throughout the universe. That would fundamentally change how we think about space exploration, resource allocation, and humanity's cosmic significance. Some government officials have expressed concern about the potential for hostile reactions from certain groups or nations if the discovery of extraterrestrial life challenges existing worldviews or power structures. There are contingency plans for everything from economic market stabilization to social media disinformation campaigns to international cooperation agreements. But perhaps most importantly, there are questions about what comes next after confirmation. Do we attempt communication? Do we intensify our search for technological civilizations? Do we accelerate human space exploration to potentially make contact? The Post-Detection Task Group is working on frameworks for all of these scenarios, but the consensus is that humanity needs to be as prepared as possible before any major announcements are made. The technological revolution. What many people don't realize is that this search for extraterrestrial life is driving a technological revolution that's advancing human capabilities in ways that go far beyond astronomy. The atmospheric analysis techniques developed for Webb's biosignature program are already being applied to Earth's climate monitoring, helping us understand our own planet's atmospheric changes with unprecedented precision. The AI systems designed to identify alien biosignatures are being adapted for medical diagnostics, environmental monitoring, and industrial applications. The data processing capabilities required to analyze thousands of exoplanet atmospheres in real time has pushed computer science and machine learning into new territories. The quantum computing applications being developed to model complex atmospheric chemistry could revolutionize everything from drug discovery to weather prediction. But perhaps most significantly, the potential confirmation of extraterrestrial life is already changing how we think about biology itself. The discovery of life in environments we previously thought uninhabitable is expanding our understanding of what's possible for living organisms. If the current observations are confirmed, we might be looking at life forms that operate on completely different biochemical principles than Earth life. Some of the atmospheric signatures suggest metabolisms based on sulfur chemistry rather than carbon chemistry, or photosynthetic processes that work with infrared light rather than visible light. These discoveries could revolutionize biotechnology, leading to new materials, new energy sources, and new approaches to medicine and manufacturing. We're not just talking about finding life, we're talking about discovering entirely new ways that life can exist and function. The cosmic perspective. So what does this secret NASA mission really mean for humanity's future? If the current observations hold up under verification, we're looking at a universe where life isn't just possible, it's common. We might be living in a galaxy teeming with biological activity, where every habitable world eventually develops some form of life. That would mean we're not alone. We never were alone, and the universe is far more alive and dynamic than we ever imagined. But it would also mean that life, including intelligent life, might be everywhere around us, operating on scales and timelines we're just beginning to understand. The technology we're developing to find extraterrestrial life is making us better at understanding and protecting life on our own planet. The perspective we're gaining about our place in the cosmos is helping us appreciate both how special Earth is and how connected we are to the larger universe. But perhaps most importantly, this mission is preparing humanity for the greatest transition in our species' history. The transition from a single-planet civilization wondering if we're alone to a spacefaring species that knows we're part of a living universe. The secret NASA mission looking for extraterrestrial life isn't just about finding aliens. It's about discovering what we are, where we came from, and where we're going in a cosmos that might be more alive than we ever dared to hope. What do you think the discovery of confirmed extraterrestrial life would mean for humanity? How do you think it would change our society, our technology, and our understanding of ourselves? Let me know in the comments below. And if you want to stay updated on the latest developments in the search for extraterrestrial life, including any major announcements that might be coming soon, subscribe to Space Prime and hit that notification bell, because we might be living through the most important period of discovery in human history, and you won't want to miss what comes next. Thanks for watching Space Prime. Until next time, keep looking up, because we might not be alone up there.